Okay, cool. So, hello everyone. Today we're going to be talking about areas, volumes, and some cross aspects of geometry that you would see in an introductory course in geometry, some basics about some basic 2D shapes, and how you can find the volumes of 3D shapes. And we're going to end with the basic info on cross sections. And finally, use volumes and cross sections to solve an interesting problem at the very end. So we want to start by kind of reviewing some basic rectangles, right? I want to review the times length, pretty basic, right? You can kind of imagine a line, a horizontal line going from the length side and going across this area. And I believe that we have a couple practice questions. So like, for example, and the other side, 7 meters, the area totals 7 times 4, or 28 meters squared. So why don't we start? So I'll give you guys like 10 seconds and just find the area of these rectangles as a warm-up. You can either feel free to just yell out your answer, or you can type it into the chat too. 3. Yes. Zachary, 12. Yep, that's exactly correct. You simply apply the formula for the squared. So the first one has, yes, this is a warm-up. This is not uh, um, what we're actually doing today. It's actually, Aaron, would you like to write this out? We don't have to. So the first one is 3 times 1, which is right, 3
Yep. So we're gonna do width
inches
times
squared. The
length.
second one is 6 times 2, so 12 centimeters squared. Uh, yeah, fairly straightforward.
Yep.
And the second one is 2 times 6, width times length, which is 12 centimeters squared. Cool. So now that we kind of have that review, why don't we do some triangles, right? And so the area of a triangle is 1/2 times base times height. And the reason that this is so is because you can kind of think of it as half a rectangle. And so whereas, yes, this is still some basic review just to make sure that we're all on the same page, right? You can kind of think of it as a rectangle that's cut in half. This is a really bad rectangle. But whereas a normal one would be base times height, and you get the full area, which is why you have 1/2 times base times height. So when you take away the annotations of a rectangle, sorry, which is the area of a triangle. Um, yeah, like that. So for example, another example is that when you have a triangle like this one, right, you have 8 as a base, and you have a height of 6, and so the area and then divided by 2 is 24. And even though this isn't necessarily the triangle you see on the left side, you can still kind of see it as a rectangle, right? You can still kind of see how it would be half of the area of a rectangle like this, right? And the area is exactly half that triangle. The area would be base times height over 2. This is still a warm up. We're still warming up. It's a extended warm up, just to make sure we're on the same page. Um, oh, my bad. Okay, cool. So I'm gonna do some basic parallelograms. And very similar to rectangles, it's also just base times height, right? And the reason is that you can kind of think of it as a rectangle with with one of the sides sliced off over there to get a parallelogram. And so that is why the formula is simply base times height, because it's simply and finally, I want to do a quick review of what we just did by doing some practice questions. The area of these parallelograms. And then afterwards, we're going to do some more complex and interesting areas. Again, feel free to either just type in the chat, or my internet is bad. You're cutting off.
Yeah, I don't think it's your internet,
Just
Hembo. It might be your internet because you are cutting off. I think, do you want to try restarting it? I can take the answers to this.
yeah, sure. You can go to. Yeah, I'm gonna
All right, guys. So while he's fixing his
do
internet, take some
my
time.
hotspot. It might be my Wi-Fi.
Just try to get through 1, 2, 6. And if you have the answers, type it out in chat, yell it out, whatever you want. Okay, we got the first one. Number one, 3 times 4 is 12. Pretty self-explanatory. Good job. Okay, 30. Second one, 5 times 6. Yep. 35. Yeah, and I think you guys get the idea. It's just multiplication. The whole idea behind parallelograms is that it doesn't matter, even if the height is an imaginary line that we draw and it's not actually a side, we can still draw the height. And as long as it's a 90-degree angle compared to the base, it still works. And it's still because it can be rearranged as a rectangle, like Cambo said. Eva, can you move on to the next slide?
Yep. And the next shape, we want to do a quick review. I know this is a lot of review, but it's just to make sure that we're kind of all on the same page in case someone hasn't necessarily learned about all these formulas. So when you have a trapezoid, what you do is you add the two bases together, right? So you add the top base to the bottom base, and you divide them by 2, and you multiply by the height. So for example, in this one, you would have 3 plus 5 equals 8. Divide that by 2, and multiply by the height, which happens to also be 2. So in this case, the area would be 8, right? So you have something like 3 plus 5. Oh, why am I unable? You have 3 plus 5, divide by 2, and then multiply by 2, which would give you a grand total of 8. So in this case, the area would be 8. If at any time anyone has any questions, please feel free to just shout it out. We're
Okay, he might have
the
just
area,
completely.
and if you
Oh,
want to find
Emma, you cut out for like a good 20 seconds. Can you repeat that?
oh boy. Um, yeah. So to find the area of a circle, you take the radius and you square it and you multiply by pi. And for the circumference, you just take the radius and you multiply by 2 pi, right? So why don't you guys try this two practice problems and find the area and circumference of each of these circles, respectively.
If you have an answer, can you type it out in the chat or yell it out? Okay, so this mysterious guy who keeps changing his name asked, do we square the r first before we multiply by the pi? And the answer to that is actually strange because it actually doesn't matter. Since it's multiplication and we're not squaring the pi as well, you can actually multiply r by itself first and then multiply pi, or the order doesn't matter because you're not squaring pi. So treat pi and r squared separately.
That's right. So, just for the sake of time, why don't we just go through these questions? And if Aaron, you could write it out as I say it. So, for the first circle with radius 5, the area would simply be pi times 5 squared, right? So, it'd be 25 pi. And for the circumference, since the radius times 2 is 10, the circumference would simply be 2 pi. I mean, 10 pi. And for the second circle, the diameter is 42, which means the radius is 21, right? Because the diameter is twice the radius. So that means the area would be pi times 21 squared, which is 441 pi. And the circumference is once again 2 pi r, which is also known as pi times the diameter, right? Because the diameter is 2 times the radius. So the circumference in this case would be 42 pi. Cool. Are there any questions? No? Okay. So now this is a little bit more interesting. So what is a sector, right? And a sector is a portion of a circle, right? It could be something as big as this, a Pac-Man, or it could also be like a slice of pizza, something that's really small, right? It's any fragment or portion of a circle. And to find the area of a sector, you want to find the ratio of the angle and divide that by 360, right? Because that shows you how big of that shows you what portion of the circle you have. And in this case, I think the angle actually does go the other way because I think it's 270. So and then you'll multiply that by pi r squared, right? Because pi r squared is the area of the full circle. So if you only have a portion of it, you would multiply by the corresponding fraction. So why don't we try a practice problem? Imagine that theta is equal to 36 degrees and the radius is equal to 5. So in this case, what would the area of the sector be? So Aaron is drawing a diagram right now. The area you want to find is roughly the one in here, which is 36 degrees. You want to find out what area is of the sector. Well, does everyone else have an answer? Zachary and Loy and dot dot dot. Have you guys managed to solve this question? Um, we will find out in a second. Just a few more seconds, just to in case anyone is getting close to solving it. Okay, I think some of us are a little stuck. So, why don't we just go over this question? So for this one, the angle is 36 degrees, right? And since there are 360 degrees in a full circle, this means that this sector is exactly 1/10 of the full circle, right? Because 36 divided by 360 is 1/10, meaning this sector is exactly 1/10 of the area of the entire circle. And the entire circle in this case is, once again, the radius squared times pi, which is 5 squared times pi, or 25 pi. And so the area of the entire sector, which is 1/10 of the circle, will be 25 pi divided by 10, which is 2.5 pi. And that's roughly 2.5 times 3-ish. So I believe that should be around like 8, 7-ish. So I think the mysterious person, you were correct. Yep. And for the second one, that one should also be fairly simple, right? Because 180 degrees is exactly 360 degrees divided by 2, right? So that means it's exactly a semicircle, right? A semicircle is a half circle, which is half of the entire circle, which means that since the radius is 10, the area is 10 squared pi equals 100 pi. So the area of the sector or semicircle is thus divided by 2, which is 50 pi.
Did you have a question, Mr. Hanbo, in the chat when you told us to stop? Were you confused about something?
Where did you get 0.25? That's the
Uh, So we didn't get 0.25, we got a similar number. We got 2.5. And that came from 25 pi here, which is the area of the circle. And we determined that this sector area, so all this area, is 1/10 of the circle. So we just multiplied 25 pi by 1/10, and that gave us 2.5. Yeah.
Does that answer your question? Okay, I think yeah, I think that makes sense. Okay, cool. So if not any more questions, we're going to move on to the next section. So these are some real actual problems. So, right, we want to try solving the areas of some pretty complex and fascinating shapes. And so why don't we go ahead and take a stab at these three questions, and then in 3 or 4 minutes, we'll come back together to discuss the answers. Yeah, so there are actually numbers inside the shape that tell you how long each side is. And that should help you determine the areas.
So we have one answer in the chat. If you think you have the first one, move on to the second one and the third one, and we'll wait for the other people to give an answer.
Zachary, you might be right, but we're gonna let you know and we're gonna go discuss the entire solution in like two or one more minute. Okay. But I think academic person just got the same answer to you, so you might be right. How are we doing with the truck question? Are we almost done or do we need a bit more time? Okay, I think for the purpose of time, why don't we go ahead and just talk about these questions? So for the first one, the doorway, should be fairly simple. Academic person, you'll find out in a second. So, the first one is the rectangle, right? You'll start with the rectangle and you have 4 times 6, which is 24. So the area of the rectangle is 24, right? Because again, it's width times length, it's 24. And for the semicircle, right, it's just half of a normal circle. And since the bottom of the rectangle has 4, right, the width is 4, that means the radius of the circle happens to be 2, right, because they share the same side as the rectangle. So that means it is half of 2 squared times pi, which is 2 pi. So when you add them together, you get 24 plus 2 pi, and that is the area of the doorway. This very fancy medieval age doorway.
So academic person, you were right when you said 30.28. So the answer to the first one is 30.28.
Congratulations.
But a lot of times what you'll see is that people like to keep this pi here. So a lot of times you might see the answer just be written as 24 plus 2 pi, like that. So it's not always necessary to multiply the pi and pretend it's 3.14. You can just have it as pi. But your answer is still correct.
Congratulations. And yes, let's move on to the Ninja Star. That one should also be fairly simple, right? And there's two ways you can think about it. One way is to calculate it piece by piece. So you can do 3 times 3, right, for the central square. And that would be an area of 9. And then for each of the smaller triangles, you have 3 times 3 divided by 2, right? Base times height divided by 2. So that is 1/2 times 3 times 3, which is 4.5. And multiply that by 4, which gives you 18. Uh, but, and that after you get 4 times 4.5, is my annotator gonna write this down?
Huh? What did you want me to write down? What, 9 plus 4.5 times 4
Times 4. Yes,
is
and that
27.
gives you 27. That's right. And but the other way you can kind of solve this is you can kind of imagine moving the triangles around, right? And what you can do is imagine that you're moving the bottom triangle upwards so that you end up getting a shape like this, right? You move the bottom one upwards, you move the left one rightwards, and you end up with kind of a three L-shaped Tetris piece consisted of three squares. And so what you can also do is just do 3 times 3 times 3, which also gives you 27, right? Because it's three squares of 3 times 3, so 27. But either way, you should get an answer of 27. So if you got that number, congratulations. Um, and finally, let's do the truck, shall we? So for the truck, it's fairly simple. You start with the rectangle and you add the triangle. So 3 times 5, which is 15. And you add that to 3 times 4 divided by 2, which is 6. And finally, you add on to the two wheels, which is each 1 squared pi or pi each. So that gives you a grand total of 15 plus 6 plus pi, which is also known as 21 plus 2 pi. Uh, are there any questions about these three area questions? You forgot about the second one. That's okay. Wait, is this review? I wouldn't say so because I think there's some pretty interesting stuff going on here. Oh, just out of curiosity, academic person, what grade are you in? Eighth. Cool, cool. Okay, so if there aren't any questions, I'm going to move on to the next set. So, now I want to kind of jump a dimension, right? We're done with 2D, and now we're going to 3D. So what if the shape is in three dimensions? Then in that case, not only does area exist, we can also talk about volume, right? Because you can, just like how you can think of area as like a line moving across upwards to cause an area, you can also think of volume as a series of, you can think of volume as a series of areas stacked against each other to form a volume, right? You can kind of think of it like printer paper. When you have multiple sheets of paper stacked together, even though each piece is very flat, when you stack them together, you get a solid that has a volume. But just because we talk about volume for these 3D shapes doesn't mean that you can't have area, right? You can also consider the surface area, which is the total amount of area on the outside of the shape, right? And that's quite different than your normal 2D areas because that'd be a combination of multiple pieces of area. But generally, volume is equal to area times height. And without further ado, let's jump into a rectangular prism. So for rectangular prism, you have the area formula of base area times width. I think that should be volume formula. But you have the base area times width, which is you find a base, the area of kind of like this base, right? Because this is your base. And you then kind of like move it across the shape to have a volume, right? So and the base area is again just your normal area that we learned about from 2D shapes. So in this case, it would be a rectangle, right? Length times height. And then finally, you kind of like stack that up and multiply by the height to give the volume. So I think that might be a bit abstract. I'm not sure. So why don't we try a few practice questions? What if we go ahead and find the volume of these prisms and type the answer into the chat once you're done? Should take very little time.
Yeah, you're finding the volume of both of these.
Maybe yes, maybe no. We'll find out in a second. And then you'll know. How come? Would you like to elaborate on that? I feel like I'm doing something wrong.
No, we're just giving everyone else an opportunity to answer. Because if we tell them the answer right now, then that would take away from
Yeah,
their ability to
just
do the
waiting
problem.
for like Zachary and Loy to give a try at this question before I announce the answer. Zachary, Loy, and the other kid with dot dot dot. Is everything we're talking about so far making sense? If you have any questions, feel free to type into the chat. Yes, I'm ready. Okay. Okay, why don't we go ahead and talk about these questions? Should be fairly simple, right? Because you kind of just multiply the three dimensions together. So for the first shape, you can do a height of 2. The bases are 7 and 10. So you multiply 7, 10, and you get 70, right? So the base area is 70. And then you can imagine stretching a stack of paper across upwards to get an entire volume. And that would be multiplying 70 by 2 to give you 140. So in other words, the academic every person, yes, that was correct. 140 is indeed correct. And for the other one, it's just a cube, right? And you can treat any surface as the base. But for the purpose of this, you might as well just treat the top face. The top one is the base, and then height is also 5. So it's simply be 5 times 5 times 5, which is known as 125. And kind of like a fun fact, 5 times 5 times 5 is equal to 5 to the third power, which is also known as 5 cubed. And it's called 5 cubed because, as you can see, this is how you find the volume for a cube by cubing the length. So, kind of an interesting fact. Uh, Now let's move on to cylinders and spheres, right? And I think this is a bit more complicated than your actual rectangular prism, right? Because with a cylinder, you also take the area of the base and multiply by height, but in this case, the area would be the area of a circle, right? So you have your pi times r squared, and then you raise it to a height to get base times height. A sphere is much more complicated. The area of a sphere is 4/3 pi r cubed, or if you use tau instead of pi, it would be 2/3 tau r cubed. Um, and just a fun fact, since this picture uses tau, tau is equal to 2 pi, right? You have pi equals 3.14, and tau is actually defined as 6.28, exactly twice as pi. And there's actually kind of like a movement of like mathematicians who believe that tau is more useful than pi. And it has to do with like sine waves and how like tau is a more natural number than pi. Um, but just for the sake of this, you just have to know that tau is just 2 pi, which is why in the tau equation it's 2/3 instead of 4/3. Uh, yes, you remember now. Congrats. And now let's do a few quick practice. So why don't you go ahead and try to find the volumes of the cylinder and the sphere, and then 2 minutes we'll once again convene to talk about it. But it should be fairly simple. Just plug into the formula.
The formula we've written right up here. So volume of the base for cylinder, volume of the cylinder, it's just volume in general.
That's okay, Zachary. Just try your best. In a few seconds, we'll explain how to solve it. Okay.
I'm not smirking at your answer. I'm smirking at your enthusiasm to know the answer. Yeah.
Yes, it is 4/3 when you're using with pi.
Does anyone else have an answer or a guess? Loy, the dot 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 person.
Okay, for the sake of time, why don't we just go ahead and go over the solutions? So, in reality, you kind of just plug the numbers into the variables, right? So, for the volume of the cylinder, you have a height of 10. So, you have 10 times pi times 5 squared, right? Because the radius of the base is 10, which means the diameter of the base is 10, which means the radius is 5. So, the volume would simply be base, which is pi times 5 squared times height times 10. So you have 10 times pi times 25 or 250 pi.
Ooh.
And whoa. And for the second question, you have the volume of a sphere. And for the second one, you simply take 1.5, right? Because the radius is half of the diameter. So you take 1.5 and you cube that times pi times 4/3. It's probably easier to use a calculator for this. And so if you do use a calculator, you should get 4/3 times pi times 1.5 cubed, which should give you 14.13.
So every person you said that you hate fractions, but this is actually a situation where fractions would help you a lot. Um, if instead of 1.5, you wrote 3 halves cubed, you would actually be able to cancel more, which means that you could write the answer in terms of fractions and you wouldn't have to actually use a calculator. So that's why fractions are useful.
That is absolutely correct. Okay, so now we want to go on to cones. And cones are really interesting because their volumes is exactly 1/3 of the corresponding cylinder. And what I mean by that is that if you raise a cone up to a cylinder, So, Aaron is going to give a demonstration right here. If you imagine that you raise it to a full cylinder, the volume of the cone will be exactly 1/3 of that cylinder. Now, this is really hard to prove. You need like multivariable calculus for this. But what you have to know is that the cone's volume is simply 1/3 of the base times its height. Uh, yes, or you could make cones out of water and then drop it into a cylinder. See that exactly 3 cones will fill the whole cylinder. And a pyramid is also really similar, right? And it's also 1/3 of the base times height. And you can imagine that if you raise a pyramid to like a full rectangular prism, it would be 1/3 of the volume of that prism. So Aaron is giving a demonstration right now. So if you make a full rectangular prism, it'll be exactly 3 times the volume of the pyramid. And one way you could visualize this is to use this diagram, right? Use this, oh my God. Use this diagram in the middle, right? Because even though this is a normal rectangular prism, right? It's not a pentagonal prism. What you can see is that you can always divide a rectangular prism into 3 parts, right? You can divide it into 3 triangular pyramids. And what that happens is that it gives you 3 equal parts that have the same volume, right? Because, for example, if you look at this one, this has a base of whatever the side length is, and then times the height, which is also the length. So say that the side length of the cube is s, then the area here would be s squared, and then the height would also be s, right? And then for these two, it would also be s squared times s, and then s squared times s, right? And then when you add all 3 of these together, you get s cubed, right? And so that's why each one of these is 1/3 times s cubed. Well, if this is more confusing, I know like this might make it more confusing for some people and clarify for others, but if not, just remember that's 1/3 of the base times height. Super simple. And now let's try a few practice questions. So why don't we take a few minutes and take a shot at these, and then in like 3 or 4 minutes, we'll come back and discuss the problems.
Let's
Uh,
go.
yes, you may use a calculator, though I don't think it's necessary. Yes, maybe so. Perhaps that is correct. Zachary and Loy and Ellipses, how are you guys doing? Are you guys almost done with the problems? Halfway through, maybe? Yes. Cool. Well, why don't we just go ahead and go through it then? Um, okay, so for the first one, you have a base of 64 pi, right? Because it's 8 squared times pi, so 64 pi. And multiply by that, you should get 1152, 1,152 pi. And divided by 3, you should get a 384 pi as the volume. And for the second one, uh, you have a base of 121, right? Because 11 squared is by the height, that gives you 1089. And in fact, in this case, you might as well just multiply by 3 because you have to divide by 3 anyways. So that gives you a total of 363 as the volume. For the third pyramid, um, you have a base of 81, right? And you want to multiply by 12 divided by 3 or 4, so you have a total of 324. And finalmente, you have a base of 25 pi, right? And you want to multiply by 12 divided by 3 or 4, so that gives you a total volume of 100 pi. Are there any questions about any of these? Hopefully, it should be fairly simple.
Good job, every person.
Congratulations. All right. So now we want to talk a bit about cross sections. And in the diagram to the right, you can see some fairly simple cross sections, right? When you have a cross section, the horizontal one of a triangular pyramid, you get a square, right? When you do that with a rectangular pyramid, you also get a square. When you do it with a pentagonal pyramid, you get a pentagon, right? And when you do it vertically with a triangular pyramid, you get a triangle, right? And in fact, there's a really helpful diagram that might really clarify things. So if you're struggling to visualize what a cross section is, this is really helpful, right? A cross section 3D figure in a plane, right? So for example, the top three diagrams here represent what you would see if you had a cross section, right? So the first one, this area here is what you would see if you had a cross section horizontally. This area is also what you would see if you had a cross section horizontally. And similarly, this is the cross section you would see if you slice it horizontally. And in fact, you can vary the planes at different angles to get different shapes, right? So for example, as we have seen with the cone, if you do it vertically, if you do it horizontally, you will get a circle, but if you do it vertically, you would get a triangle, right? This is if you do a cross section like this vertically. And with a cylinder, if you do it horizontally, you once again get a circle. But if you do a vertical one, you actually get a rectangle, right? And in fact, if you do one near the edge, you would get a smaller rectangle, right? Um, and with a rectangular pyramid, it's really similar. And finally, with a triangular prism, you would actually also get a rectangle if you do a smaller cross section like that. So I think the point of these cross sections is that sometimes they help you to work with a certain area within the shape, and it helps you to solve some questions. But before we do that, I just want to mention that you can also tilt angles too, right? So it doesn't have to be just perpendicular or parallel. You can have these wacky angles, and it will actually give you some really interesting shapes, right? You can do that, and that will give you an ellipse. And in fact, you can also do a plane that kind of like goes directly across this way. and that would give you a parabola, which you would learn about when you take high school algebra. Um, but before I move on, are there any questions about what a cross section is? If not, I want to spend the remaining of class 5 minutes to solve this fairly interesting question about a frustum. So, frustums are the portion of a cone or pyramid which remains after its upper part has been sliced off by a plane parallel to its base. So, why don't we try finding the volume of this frustum? I think this could be a really challenging and interesting exercise. Right, so first things, I want us to visualize what a frustum is, right? So if Aaron, you could help me draw this. A frustum is what remains when you cut off a full pyramid and your leftovers with kind of like the stump, right? So in this case, you started off with a full uh, rectangular pyramid, but then you cut off the top rectangular pyramid, and so you end up with kind of like this trapezoidal shape, right? And so the way you would find the volume of a frustum, what has been cut off, you find the area of that, and then you subtract the area of the smaller one, and that will give you what is remaining. So why don't we try to solve this, right? And I think the first thing we have to do in order to do that is to find the height of the entire pyramid, right? Because we want to find the area of the entire, I mean, the volume of the entire pyramid first. And to do that, we will utilize cross sections, right? Now, this is going to be pretty hard to draw, but if you imagine doing a vertical cross section down the middle, right? Like a vertical cross section down the exact middle, you would get a triangle. Just gonna visualize this. You would get a triangle in the middle, right? So you get something like, I'm gonna use a different color, right? You get something like this. You get a triangle. Oh no. Oh my God. A triangle. Right? Like that. And then what you see is that these are actually similar triangles, right? Because you can do another triangle here. And what that means is that since the bottom half is 6 centimeters, the top half would also be 6 centimeters, right? And this is a bit messy, but the way you see this is that you look, oh, thank you, thank you. You look at the sides, right? Because this side, this part here is exactly half of this part, right? Because it's half the square. And the square is 2 on the top and 4 on the bottom, so it's exactly half, right? And then they also happen to share two angles, right? Because they both shared this top angle, and they also share these angles, which happen to be the same, right? And so what this means is that it satisfies um the the S the ASA theorem. No, the ASA theorem for triangle similarity, which you might know or might not know, but basically what this means is that these are similar triangles, which means that we can infer that the top length is also 6. So basically what we have found is that the height of the entire pyramid is 12. So we can calculate the volume of the entire pyramid to be 4 times 4, which is the base. That should give you, uh, Aaron can write this down. You can have a base of 4 times 4, which is 16, and then you multiply that by 12 divided by 3, which would give you 56. That is correct. But remember, we want to find the area of the bottom part. I mean, the volume of the frustum, right? So we want to subtract the top part. And so the top is just a regular pyramid. It's 2 times 2 times 6 divided by 3. And that gives you, I
I think
believe,
it's actually 64. Or actually, yeah, it's 64. 4 times 4 times 4.
oh yeah, that's right. Yeah, 64. And then you subtract 8 to get 56. Yes, the answer is 56 for the frustum. And so, yes, congratulations. Uh, does anyone have any questions about what you just did? Zachary and Lloyd, does this make sense? Cool.
Do we
Well,
all know the concept of similar triangles, or is that potentially something we should go over again in the future?
Zachary and Lloyd, have you guys studied similar triangles in school? Do you know what that is? No. Okay, yeah, we can go over that next time. Cool, cool. That's good to know. Well, if there are no more questions, we have reached the end of our lesson tonight. So thank you very much, and stick around if you have any questions, and if not, we'll see you next week. Thank you very much. Bye, Zach.
DK, did you have a question? If you have any suggestions, yeah. What's your question?
That's a great question. One that I'm afraid I might not be able to answer. Oh, it's choice. Huh,
Oh,
nice.
we're not.
Well, if there are no more questions, thank you very much, and we'll see you next week.